All right, welcome everybody. We'll go ahead and give it just another minute. Quite a few people are still jumping online here. All right, we'll go ahead and get started here. It looks like a few more folks are still jumping in, but we'll go ahead and kick off here. So welcome to the Oregon ITE SimCap webinar. So it's been quite some time since we've had a webinar, a little over a year, so things have slowed down a little bit with COVID, but we're hoping to pick things back up again and hopefully even have some in-person events towards the end of this year or potentially early next year. Today we'll have our presentation from the Aimsun crew, and our focus will be modeling ICM and ATM applications with Aimsun next. So appreciate everybody attending. We are recording this webinar, so we'll have a link afterwards where this will hopefully be able to be viewed after the fact. Quick agenda, starting off with some Oregon ITE announcements. I know this particular session was broadcast to folks outside of Oregon ITE, so I certainly appreciate those of you who are not local to the Oregon section for participating. So with our local announcements, we do have a call for election candidates for Oregon ITE Secretary Treasurer. The deadline on that is coming up rapidly at the end of September. So if you are interested in being a candidate for our Secretary Treasurer, please email oregonite1@gmail.com. We do have some upcoming events. Our October webinar, again, this is not the SimCap webinar, but this is just the general Oregon ITE webinar, is the Division Transit Project. This is TriMet's first BRT line. This will be presented by City of Portland staff on Tuesday, October 26th. And then coming up in November, we have our Traffic Bowl. As it was last year, this will again be a virtual event, but always great to have all the local college teams competing at the Oregon ITE Traffic Bowl. You can find registration details on our website. It is free of cost. And then just another quick announcement on Oregon ITE SimCap. So if you're not familiar with SimCap, this is really our simulation and capacity analysis users group. It's a subcommittee of our Oregon ITE section. And really we focus on all things modeling, operations, capacity, data, anything sort of in that realm. And so if you have any suggestions for presentations, maybe you have something you want to present or you have ideas, feel free to email at oregonite1@gmail.com. We're always looking for some new sessions. We are currently in the works for a first quarter 2022 doing a co-presentation on data analytics with the Oregon Model Users Group, or OMUG group. So today's workshop, we also would like to thank our sponsors. So we have quite a few of you out there. It's with these sponsors that allow us to offer these webinars, and when we do get back to in-person events, to keep the cost down on those events. So again, thank you to all of our sponsors. These also help out with our scholarship contributions as well. So on to the main presentation. We have Shaun, Bready, and Matthew Juckes presenting from Aimsun on modeling ICM ATM applications with Aimsun next. So Shaun, I will kick it over to you.
All right, thanks, Randy. Get my screens in order. Make sure I'm all good. Everybody's seeing nice big blue screen, right?
Yep, all good.
So thanks, Randy. As Randy said, my name is Shaun Bready. I'm the regional head of business development with Aimsun Inc., which is Aimsun in North America. And today we're going to be presenting for you. I'm going to go ahead and turn off my video just to make sure things go smoothly. Do we still got my screen, or did we lose the screen?
You're good.
Okay. And as Randy said, we're going to be talking today about modeling ICM ATM applications within Aimsun Next. We already did our little introductions. Kind of the order of what we're going to be going through today, we're going to do a quick overview and a background of the company, and then we're going to do an introduction to some of the things we offer within the platform, the Aimsun Next, Aimsun Live, and then we're going to get into the case studies of the ICM ATM, being the I-15 corridor in San Diego and the I-4 corridor in Orlando, Florida, and then we'll finish off with some Q&A. So to start off, Aimsun is considered the international leader in transportation planning, simulation, and prediction. We were founded in 1997, and Aimsun has supported transportation agencies, consultants, research institutions that seek to optimize smart, sustainable mobility. We're a company that is solely focused on algorithms, software, and the operational professional services for mobility applications in transportation planning and engineering, mobility management, and AV or autonomous vehicle testing. Aimsun currently is active in 90 countries and counting worldwide. We have 7 offices. The North American office is located in New York City, and the headquarters is in Barcelona. We have an office in Paris, Sydney, London, Melbourne, and Singapore. And there are currently over 150 major Aimsun citywide models. That includes places such as Paris, London, New York, Abu Dhabi, Sydney, Singapore, Hong Kong, Rio de Janeiro, and so on. Some of the governments and private sector and academia that are currently using Aimsun products, just some listed here. I'm not going to go through all of them. This is specific to what we like to say the ones in North America, but not limited to all these. Just wanted to highlight a few. Maybe you say your own name, maybe you see some that you recognize. Now getting into what we're really going to be talking and highlighting today is a little bit of the portfolio, is Aimsun Next and Aimsun Live. To start off with Next, Aimsun Next allows you to carry out traffic operation assessments of any scale and any complexity. Most of the applications are endless, but the most common ones you are probably familiar with are assessments and optimization within the transit signal priority, TSP, or bus rapid transit, BRT schemes. We do feasibility studies using high occupancy vehicles, HOVs, or high occupancy tolls, HOT lanes, impact analysis, environmental impact analysis, toll and road pricing, evaluation, demand management, signal control plan optimization, safety analysis, so on and so forth. And then Aimsun Live is the engine for really any advanced traveler information systems or advanced traffic management systems, including transportation demand management, congestion pricing, real-time transportation information, road and weather type management, traffic incidents, which is what we're really talking about today, air quality. And a good way to separate between the two is one way we like to refer to them is Aimsun Next is really our offline type of model, and Aimsun Live is our real-time, quote unquote, online modeling platforms. We like to refer to the Next platform when we talk about it as being the true integration of 3 modeling tiers, the macroscopic, mesoscopic, microscopic, all in one tiers of modeling, which really allows the users to efficiently and strategically implement the use of these models as solutions in both active and future projects. Our single multi-purpose, multi-layer simulation package benefits the users by allowing them to choose the right tool for the project rather than just fitting the project around the tool. It also allows you to build an extensible simulation model on any scale using the single all-in-one package. Originally, Aimsun Next has really grown from just a micro simulator to the fully integrated platform that fuses the micro, meso, macro, and now we're including the pedestrian simulator, travel demand modeling, and even our hybrid simulators, which we're going to talk about. I'm going to talk about and touch on in just a second. Aimsun likes to use a unique traffic assignment framework. in order to get to the starting point before we do any micro simulation or meso simulation, we have to start with some kind of an assignment. And within the platform, we can start with either the macro assignment within the platform, or we can bring in these types of routes from an external source, such as something you would be more familiar with, the regional travel demand models. Once that's all done, they are created, and then we have to create some kind of path assignment for the type of model that we're looking forward to. And really that's either using what we like to call a one-shot stochastic route choice, or SRC, or the DUE, the dynamic user equilibrium. For those that aren't familiar with kind of the wording between the two, I like to think of stochastic route choice as you woke up this morning to go to work, to drive into work, you looked at Google or Waze or whatever you were using, and it told you what the fastest way from point A to point B was. That would be your stochastic route choice. Whereas if you did that for the entire month of, say, September, and you did that every single day, and then you recorded every single day which route you took, by the day 30 or 31, you're gonna be able to analyze and say, I took this trip 17 times, this trip 10 times, this trip 3 times. My fastest time on average was this. That would be your individual DUE. And then you can imagine if every single trip and every single route combined throughout an entire network was combined in that would be that DUE, that user equilibrium. Now, this is a really important step when we're talking about the ICM, incident corridor management type of studies, because when we're getting into how traffic may route during these various types of events, we want to be able to utilize both SRC and the DUE for predictive and future. Some of the world's largest models have been built using these Aimsun tools, most of which are in that mesoscopic scale. San Diego being very popular within North America. Most people have heard of that. Abu Dhabi is one, the entire city of Montreal. And this is really thanks to the capabilities of the Next all-in-one platform and the use of the meso micro hybrid simulators. We're able to run these large scale models in a very reasonable time frame. Touching on that meso micro hybrid, since that is one of the reasons we're able to do this rather quickly. The video I'm just showing you is really how easy it is to take a large scale meso model and then create what we like to call a micro pocket that would then be able to be simulated to get the operational readiness of a micro simulation, but at the same time being able to have anything outside of that micro simulation area feeding the same information you would get. So you're not just cutting it off from the rest of the world, and you're getting the details, the demands, the functionalities, the delays coming from the outside and working their way in. And as I mentioned earlier, we do have the same option at a meso micro to do it at the macro meso when that is of interest. So getting into kind of the transportation system management and operations side, and how Aimsun is actively supporting these types of TISMO projects. TISMO is that set of strategies that focuses on the operational improvements that can maintain and even restore performance of existing transportation systems before extra capacity is really needed. The goal here is to get the most performance out of the transportation facilities we already have. The required knowledge, skills, and techniques to administer these solutions that can be quickly implemented at a relatively low cost. This may enable transportation agencies to kind of stretch funding to benefit more areas and customers. TISMO also helps agencies balance supply and demand and provide flexible solutions to really match the everyday changing condition of what we're doing. With that being said, so what we're about to get into, what Matt's going to be touching on over the course of the rest of this presentation, is how Aimsun Next and Aimsun Live are helping to implement these strategies and solutions in the ICM ATM part of the world. Specifically, but not limited to, traffic incident management, active transportation and demand management, integrated corridor management, and really that access management. And with that being said, I'm going to pass it along here over to Matt, who's going to dive into a brief introduction of Aimsun Live, and then we're going to really get into these case studies that we've been working on. Matt?
Thanks, Shaun. So to give you an idea, Aimsun Live is where we've taken Aimsun Next and used that engine to bring it to an operational world where rather than looking at just the planning and the long-term forecasts, we're now looking at the short-term forecast, short-term predictions, and using those real-time predictions for helping operation decisions be made. So a lot of the times, Aimsun Live is either a standalone or an integrated part of an ICM system and the decision support system in helping understand the challenges that are associated with managing both reoccurring and non-reoccurring congestion. Next slide. So we've been doing this for quite some time, and obviously we've gotten better with it with each time. Our first real Aimsun Live was in 2006, where we had a system with the city of Madrid, obviously being based out of Spain. That was an easy client to sort of test it out with. And it was really for those response plan analysis. In 2009, we opened our office in New York. And then in 2011, we had a number of different projects in place, two of which were in the US. The evacuation and recovery modeling and simulation tool for the Port Authority of New York and New Jersey, and also the I-15 ICM San Diego system. This was part of the US DOT's pilot program for ICM, Integrated Corridor Management Systems. It went through many rounds, and in the end, for full deployment, San Diego got selected, and so did Houston, or not Houston, sorry, Dallas, Texas. And we'll get into a lot more we'll get into a lot more detail in that one as we go into the next slides. From there, we've really continued to do it with other systems and other projects. We've also, ever since 2018, we've started looking at the ability to do much larger systems. So whereas the I-15 and the M4 Smart Motorway are really looking at a corridor, with the Florida project and some of the other projects we've looked at, we start looking at different things and really looking at a mesoscopic to do is to broaden the simulation. What mesoscopic has allowed the size of the model, rather than looking at a operational real time. We've made a lot of advances in how our mesoscopic simulation works in providing operational richness. And finally, recently we had the Highways of England Oxfordshire Aimsun Live, where we actually used it rather than looking at just delay and traffic. We also looked at how real-time operations can impact air quality and emissions. Next slide. So what are the challenges that traffic management presents to us? We have the reoccurring situations, AM and PM peaks, special events that are planned well in advance. And for those cases, we don't necessarily we can prepare beforehand, and we can use time series analysis or really data analytics to understand the answers and come up with some of those solutions. But where Aimsun Live really takes it to the next step is those non-reoccurring situations. So situations that don't occur every day, that you don't have a history of data that allows you to build the analytics off. No one incident is ever the same. It may be at the same location, but one may last 15 minutes, one may last an hour. Two cars being pulled over on the side of the road, if one's on fire versus if it's just somebody changing a tire, the impact on the traffic around it is significantly different. Also, everything else that's going on while that incident is happening, is there any construction closures? Is there a weather event? Are there any other things going on? These all feed into a simulation and are used through Aimsun Live, where we're allowed to really understand the differences between reoccurring situations and non-reoccurring situations. Next. So in the offline simulations, we have the micro, meso, macro integration, large scale static and dynamic models, and we're able to run faster than real time. Where we take this feeds into Aimsun Live, that it allows us to do analytical monitoring of the system, understanding how the demand is changing over time in real time, providing predictions, and I'll get into a little bit more detail of that, and then adding that all together to do decisions for support, where we're looking at alternate plans in managing the traffic situation and coming up with the optimized plan to be pushed to the field. Sorry. So for the monitoring, this is where, before actually getting into the micro simulation, mesoscopic simulation, we're really looking at more of a macroscopic data analytics side of things, where we're taking all of the rich sensor data provided both from the historical data sets and the real-time data that we get. We put that into a data analysis. We come up with a pattern matcher module. What that is we figure out which pattern is best suited to match what's happening in the field right there. And the patterns are a set of 15-minute demand files that represent all the possible demands that could happen in this area. For example, there's over 1,000 different demand patterns for the San Diego system. With that, we can then do a micro, meso, macro level assignment and understand how good our quality and how good our predictions, because we do these analytical predictions that give us the first hour of what the demands are going to look like, and we can provide the reports for that to show the quality. Next slide. So from there, we take those analytical predictions to provide us with the proper demand, the proper pattern that can fit into it. That then fits into a micro simulation. So when we deploy an Aimsun Live, what we end up doing is we end up having a simulation on one of our machines or in the cloud that runs all the time. And every 5 minutes, it's updating what the next hour is going to look like. This provides the metrics to a DSS or to our own incident detection module that allows us to understand what's happening on the roadway, what the congestion is going to look like, and is there a change between the historical norm, what it normally looks like, and what it looks like now. This then gets used to be able to identify the need for a response plan. What should be noted is when we do these simulations, we tie into all that robust real-time data so that we're capturing all the states of the ITS devices, what state the signals are in. We're catching all the events, be it a traffic incident, a construction event, so that we have any reductions in capacity, and then any other events such as ramp metering actions or weather events. Next slide. So once we've provided all of that prediction data to the DSS will determine whether or not there's a problem in the roadway. And when it does determine there's a problem in the roadway, it will detect the need and build a set of response plans. Typically in our Aimsun Live deployments, we are able to run anywhere from 6 to 10 simulations simultaneously. We could run more, but it's usually a hardware or a constraint of the cloud, how many we could run. With that, the DSS will create a number of response plans. Here, for this example, we've created 4 different response plans and have the do nothing scenario. That gets fed into our simulator engines. We will simulate the simulations for each of the different response plans and the do nothing scenario, and then we compare all the results of each scenario to the response plan, to the do nothing, and that gives us a score for each one. With that scoring, we're able to determine which of the scenarios will have the best impact and help traffic out the most. And this can be configured to be against delay, against emissions, and all the different metrics that we're able to get out of the Aimsun model. Aimsun Next has pretty much every metric you could want for traffic analysis. And from that, the decision support system, which is usually attached to the ATMS system, is able to select the best response plan to implement. So here's the typical architecture for Aimsun Live, where we have a data hub with the response plan lookup. That data hub can either be a playbook of response plans or a dynamic generation of response plans. That feeds into Aimsun Live. We have our historical data that includes our historical patterns and our historical travel demand that we use to feed the demand matching tool and the sensor server. With that, we combine the historical data with the live sensor data, equipment status, and traffic events to really get the robustness out of Aimsun Live. We'll do the analytical prediction to provide what the predicted demand should look like. We bring in all of that real-time data to understand what the supply side looks like and any incidents in the area. We can then feed these predictions to do incident detection. We sometimes do that. Sometimes our partners will do that. And then we feed in, once an incident has been detected, the response plan sets that need to be evaluated. They go into the response plan evaluation tool, and then that comes out and provides the scores and the traffic management plans that need to be pushed out to the field. One thing that when I first did this one, I worked on the San Diego one, and I had been doing typical traffic modeling where we really look at the models 5 years out. You know, you do your base case and then your 5-year forecast. This was the first time doing a model where you know how good your model was an hour after it was simulated because all of the data has come in. So we have our quality manager as part of this, and as the horizon of the simulation, which is typically 1 hour, comes in, you're able to see the GEH results, the percent differences, and all of those metrics that tell you how accurate the simulation was. We actually use that then to understand whether or not we need to go in and reprogram, retrain our models for the demands. So what are the advantages that Aimsun and Aimsun Live bring to this? First of all, with an Aimsun Live and with our tool, you have the choice now of selecting the appropriate model level. You can do microscopic for those really detailed corridors. You can do mesoscopic for the regional capture. And if you have a combination of the two, you can actually do the hybrid simulations. We also now have the macro-meso hybrid, which can be done for really large area forecasts. We adapt to the user requirements. So unlike a typical modeling project, any ICM project and these systems type projects come with a significant list of requirements that we meet, and we then do acceptance testing when we deliver the system to the client. We have a customizable user interface for tracking and understanding how the system's running, and even for testing out new response plans. Also with our interface, we have the quality assurance module. We have a very comprehensive analysis of travel patterns, which helps us to understand the variations in the patterns and demands throughout the day. We can use this tool both for planned and non-reoccurring and unexpected events. And the key here is we're providing a very detailed, accurate level for those non-reoccurring events that provides answers within 2 to 5 minutes. And we have a very modular architecture. Like I said, sometimes we do the incident detection or the scoring, sometimes our partners do. So we are able to fit in the pieces as we need. Yeah. So now we'll get into the case studies. So the two we're going to look at is first the original one for us, which really has become a pilot project for, you know, the pioneer project, I would say, for these types of ICM projects. And that's the San Diego I-15 ICM. So this was part of the US DOT FHWA pilot project. It's won numerous awards for being one of the first of its kind of this type of traffic management system using a decision support system that's got integrated predictions as part of its decision process. Next slide. So the predictions, the old way before this was to detect an incident, verify it, and respond, a very reactive way of dealing it. The new way that the I-15 really brought to the table was to predict the conditions, act on the prediction, and try and prevent the problem areas and the problem congestion before it actually happens, and be more proactive than reactive. Next slide, please. So the San Diego corridor, it's along I-15 entering into the city of San Diego. It's about a 35-kilometer or 20-mile stretch of interstate plus arterials. The arterials are key because these are the diversion routes. One of the key elements of this was being able to understand when things happened on the I-15, what were the best diversion routes to try and get traffic to use, and then also use those ITS devices on those diversion routes to change the signal timings and the ramp metering to facilitate the extra demand on those arterials. So with the I-15 ICM project, we deployed two of our elements, the network prediction system, which is the constant monitoring every 5 minutes, plus the 24/7 analytical predictions. So you had both the analytical and the simulation base to detect potential future congestion and feed an expert system, the business rules engine, which was put in place by Parsons, that creates the response plans and then feeds it to our second module, the real-time simulation subsystem. That was the system that would evaluate the response plans against a do nothing to come up with a congestion-based or a delay-based metric and scoring. The key here was really looking at the ability to provide these predictions to the INET tool. It would analyze against the historical data and understand if in 15 or 30 minutes there was going to be a congestion, a drop in speed, or a queue length that would exceed and trigger the need for a response plan. So one of the keys for all of these systems is a lot of data. So this gives you an idea of all the different systems, external systems that the ICMS system connected to, and that in turn we were part of. So you can see at the bottom the NPS and the RTSS, the network prediction and real-time simulation systems. But we were getting data from the ramp metering information system, the regional arterial management system, which controls all of the signals, the arterial travel time system, the lane closure system, which would tell us of any construction events that were in place. Of course, we were also connected to the freeway management, the ATMS systems that would provide us with any real-time events happening, any accidents, crashes, closures, so that we always had that information coming in. And of course, the congestion pricing system, because the I-15 has some hot lanes that have dynamic tolling with a price that changes based on the congestion levels and the density on those lanes. So in the end, once we were able to deploy the system, we did find that we were able to, using analysis modeling simulation and Aimsun next, because I'll get to one of the downfalls of this project, but one of the things we were able to track was the annual benefits and savings in person hours of savings, with a 33.3% savings on people's travel time, and also the variability reductions and the ability to keep a constant travel time. We also saw that the evening peak in the northbound, we definitely saw a bigger percent savings from implementing these strategies than in the base case. I should say that these are still running, and so the system is still up and running. And one of the things to note is that everybody moved very fast on this one. And one of our lessons learned is, as you're building the system, to make sure you collect the data hub and the data collection system is in place as soon as possible, so you can collect the before conditions. So how did the system react to events before, and what sort of delays did you have? So you have a better before and after comparison. Next slide. So now, looking at the Florida D5 Regional Integrated Corridor Management Software, this is one of our newer deployments with District 5 of FDOT. We were part of the predictive model, obviously. That for this one, we were predicting out 30 minutes and using a mesoscopic simulator. There was also, as this one, an offline tool for signal optimization. The tool itself was built by Swery, but what it does is it uses a combination of HCS optimization tools with Aimsun predictions using a micro-meso hybrid to calculate the benefits for the corridor, not just for the individual intersections. And then it also had a smart signals that were upgraded to be able to integrate with this system. So advances for a regional system beyond a corridor system. In yellow, you see the main area of the I-4 corridor that was in question. And had you done just a microscopic corridor model, that yellow area would have been the size of your model. Because we went with a dynamic mesoscopic simulation for the base, the area was expanded significantly, and the blue border in the map to the right shows the boundaries of the area that is modeled, and is modeled every 5 minutes. We run a simulation, and they take about 2 minutes to get the full 30 minutes prediction. Also, there's a lot of signals and corridors, so the enhanced signal optimization evaluations were added to this in an offline tool. Next slide. So one of the things, big part of this project was first identifying the detour routes. They're not dynamically generated, they're predefined detour routes. What you see here is an example of one of the segments of I-4 highlighted in yellow that would have an accident that would close some of the links or all of the links of that segment. And then shown in the various colors are the different detour routes which were available to the system, and the signals also along those detour routes that could be changed into a more proactive stance for the new direction of traffic demand that would be coming. These would be used to then generate the response plans, or are used to generate the response plans that are then fed to the simulator, and then the simulator will tell which combination provides the best score. Next slide. So with the non-reoccurring incident detection and response, the design time, they created a repository of response plan actions and diversion routes. So the signals, the ramp metering, the message signs, and also in combination with the diversion routes. One of the things they did here using the SOT and the traffic engineers is each signal in the system has what it would be called an ICM directional signal timing plan. So it's a signal timing plan that isn't a time of day plan, but one that is meant to handle an ICM diversion. One of the things that happens with an ICM diversion is every now and then you'll have one of the signals which will have a significant increase on the left turn. If you don't have signal timing to handle that, then that will become your failure point for that response plan. And then a rules engine was developed that mapped the event attributes to the response plans. From that, the rules engine would select the response plans for active incidents and generate anywhere from 2 to 6 response plans. These would get sent to our mesoscopic simulation engine, Aimsun Live, which predicts out the measures of effectiveness for 30 minutes into the future. Right now, we're mostly based on delay and passenger travel times, but because we have all these metrics that are available, we're going to be looking at throughput and also emissions as part of the future enhancements to this scoring system. Finally, once the ICM system has scored the best plan, it will send out notifications to all the agency approvals. And once approved, these then go to SunGuide, their ATMS system, and to the operators to enact all of the elements within the response plan. Next slide. So one of the things which was interesting for this project, and I wanted to show because it really ties in the Aimsun Next with the Aimsun Live, is the conversion from a 24-hour base model to a 24/7, 365-day-a-year model. So the project initially started with Cambridge Systematics, who built the base model for this project. It covers that whole area. They took the regional model, the CTR, I think it's the CTRMA, but I may have that wrong, but they took the regional model for that, imported it into Aimsun, which is usually our starting place for most of these, because then you have a good demand to start with these. Then they went through a collection of the data, got the data for a typical day, and were able to calibrate this model to represent a full 24-hour period. From that, we then, Aimsun, went in and connected to the RIDIS system and to the ITSQA system, one of FDOT's own proprietary system, to collect a year's worth of data. We use that data to do cluster analysis. This is where we analyze all of the data that is available and understand the different patterns, the different day types, and how each pattern and day type looks as far as demands, and are able to group them together so that we end up with about anywhere from 11 to 14 different days. I think with the Florida one, we're at 13 right now, different demand day types, which each demand day has a 24 hours worth of 15-minute demand matrices. From there, we take the model and we connect it to all the live data sources, the signals, the variable message signs, the ramps, the tolling systems, the detection, and any events happening. With that, we're able to provide the analytical predictions to the SunGuide system, the rolling predictions to the ICMS, and then as evaluations are needed, we're able to provide the evaluations and the scoring for the response plans. Next slide. So this is just an example from the ICMS system of the proposed, the response plan process flow. So here is where you have first all of the external historical and live data coming into the system, into the data fusion engine. It comes into our monitoring system where we run the prediction engine, and that engine runs and it predicts out the next half an hour. Then they look at it and they go, are there any alarms, any event alarms? Were there any congestion events? If it's no, then no response plan is needed. If it's yes, then we go back, we go down, and they take the network predictions to build the response plans. From there, those response plans are sent into the prediction engine, where the model will evaluate each of the response plans and come up with the scores. One of the keys here is every time we run a simulation, we store the prediction results and we provide the quality for those prediction results so that it can be understood how good those were from the DFE. Then from there, the ICMS sends it to the operator, to the IEN, where the operator looks at the response that it's given and makes the decision whether or not to accept it. If it accepts it, then they're pushed to the field and it goes into a monitoring stance, where essentially the evaluation engine will monitor the conditions and every 5 minutes look to see if anything's changed. Should this response plan be canceled? Should this response plan be cleared? Should it be modified because now the congestion's gotten that much worse and they need to change things? So that gives you a sense. I've only touched high level on this flow chart, but this was done also for the San Diego ICM and is a standard practice that is done when we do these sort of flows for the RICMS type projects. Next slide. So just for the RICMS, I just wanted to share that this is information on this is available from the Florida Smart Roads projects. Jeremy Dillmore and Tushar Patel are the FDOT representatives. Jeremy's the TISMO engineer and Tushar is the project manager. Their email addresses are here and they're available for any questions or comments, or if you wanted to get a demo of the system or anything like that. And I think with that, that ends our presentation.
All right, well, thanks, Matt and Shaun. Certainly quite informative there. So we have about 15 minutes left of time. If anybody has any particular questions, go ahead and type them in the questions box, and we can make sure we get those questions answered. In the meantime, I guess I have a question. When you're looking at real-time data inputs in terms of volume, often a lot of the times that volume source is your throughput. And there's always the issue when you're dealing with congested, especially congested freeway segments, of demand versus throughput. When you're taking that field data, are you making adjustments to go into the model to account for that demand versus throughput issue?
So when the monitoring system and the analytical predictions are taking place, one of the things they're comparing is they're not just grabbing the volume, they also grab the speed associated with that volume so that we can understand the congestion levels. Because we did in the San Diego project, what we realized really early on was once the speed dropped to a certain point, Caltrans was just zeroing out the volumes. They were being zeroed out because of that problem of as congestion happens, the flow actually drops. So we use a couple of things like the nearest neighbor sort of approach, where we look upstream until we get to a point where the speed is still good. And also we try and make sure when we're modeling, we're getting the end so that we don't have the congestion spilling back. Obviously you can't always have that, but we try to keep it so that we're getting a true representation in the corridor or the region of the demand, not just the count.
Okay, excellent. That makes sense. And in related fashion, what is your, I guess, analysis interval in terms of peaking profiles? Because that's often another aspect that is important to properly capture to get the proper buildup and dissipation of congestion.
Matt, you're muted.
Yeah, I don't know if we're losing his connection there.
I think we lost his connection, and I think he was muted the whole time. Just see him talking. Matt, can you hear us? There you go.
I can hear you. Could you not hear me?
No.
No.
Oh, geez. I was muted the first time, so that was my fault. And then I guess you lost me. All right, I'm glad I'm on video so you could see I was talking. For my third time of saying this, we have a system in place which allows, we have those patterns, as I said, 13 days. Those are split into 15-minute profiles, and you can see the demands from that. What our analytical predictions are doing is they're capturing the nuances from, no one day is the same. And it's looking at it every 5 minutes. So we capture the slight change, and although it might be Monday at 7:15, for the next 15 minutes, Tuesday at 8 the demand from Tuesday at 8 a.m. is actually more representative. So we're able to capture that, to capture how the peaks and flows happen. And you can't just take any that pattern can't be taken from any day and just applied bluntly.
Gotcha. Okay. Looking to the board here, I'm not seeing anything in the chat or questions. We still have a handful of folks online, so if anybody does have any questions, this is the last call to get those questions in. Likewise, if something comes to mind after the fact, you have Matt and Shaun's email on the screen there.
Although I guess my email doesn't have an R in it.
Oh. We did have a question come in. This is from Bill Cisco. How frequently do these DSS systems lead to actions being taken, automatically or manual, over the course of a week, month, or year?
Oh, that is a really good question. I'm going to go with the San Diego system because the Florida system is still fairly new. It's been in a sort of a soft launch for the past 6 months. But oh, there, Shaun's changed the email. But the San Diego system, I would say we were seeing anywhere from 5 to 10 events per week and about 150 to 200 over the year, where not only did something happen that required a response, that required an evaluation, but that a response plan was generated that had a benefit well enough for implementing in the field. One of the things that really comes out of this that isn't always clear is this system also shows you not every event requires you to come out with a hammer and try and come up with a plan that can fix it. Sometimes some events, just doing nothing is actually the best solution. And this system will tell you that by telling you that the response plan has a negative impact on it. Hopefully I answered that question.
Artie, any other questions? Great question there from Bill. All right, Jim Starrock has a question. For the San Diego events, how many were incidents approximately?
I would say about 80 to 85% of the events that cause congestion are caused by an incident, because really they're the ones which have the biggest change from a historical travel time perspective. There were some events, an interesting one is weather. In San Diego, it doesn't rain. So when it does rain that one time a year, all the oil comes up off of the roadway, and the capacity of the roadways drops significantly, and it's just a nightmare. I got to experience that once. So there wasn't that many non-reoccurring congestion issues that triggered the system in the San Diego system. We may see it a little bit more in the Florida system, but the Florida system currently is more configured to respond to response time, to when there's an incident on the roadway.
All right. One more question that came in here. For the Florida project, there was a connection to HCS for signal timing to be simulated. How does this connection work?
Sure thing. So they have what they call the signal optimization tool. In there, the logic, we worked with I didn't, Swery worked with the University of Florida and brought in the logic of HCS. From that, because we have all the data and a lot of work was put into having a TMDD, traffic management data dictionary feed from the signal providers that provided all of the information for the signal timing. Operators or the traffic engineers for the towns can go in, they can select a number of intersections or a corridor they have to be sequential intersections. And what happens is they then can select either an exact day or a range of days, because all of that volume data is available, and it builds out the volumes for that corridor. That then gets analyzed in HCS's, I think it's called Streets or something, the optimization tool that HCS provides. This then comes up with a new set of signal timing plans and the coordination for those signal timing plans. This then gets fed into the model, and we model the corridor of signals in microscopic, and then we do a boundary around the outside in mesoscopic, so that we're not getting just the impact on that road, but also the impact that happens when traffic might actually migrate to that road because you've increased the capacity of it. Those results are then provided to the operator in the form of MOE metrics and scoring based on both the HCS and the microsim. So they've got a combined set of metrics to decide whether or not this plan should be put in place. The neat thing about it is, because they have all of this inventory data from the signals, you can see the schedule and everything like that when you're making your decisions to optimize the corridor.
Great. Next question that came in here. The Florida case used predetermined detour routes. I can understand the reasoning for that, but to what extent do you think those would be followed when drivers have actively updating navigation systems in vehicle?
That's a really good question. The hard ones are the really good questions, right? One of the things is that we sort of watched the ways traffic was reacting from the counts when there were events, to see what the changes would look like and be able to capture that. The other thing that is being worked on is to feed some of that information to those traffic providers, or through another app, through the Florida app, to be able to provide that routing to the drivers. One of the things with these diversion routes was there wasn't many other, if you were going to take a route off of the roadway, they were fairly straightforward routes without much real other choice. It was fairly clear once you told them which exit to go off and which road to take, which way you'd go.
As a former Daily Ways user with a fairly lengthy commute, I can speak to the variation of routes. Between my commute, I probably had 30 different routes, occasionally going down narrow single lane roads, gravel roads. It was amazing the paths Ways would take me to work sometimes. And I know some agencies have worked with those providers to limit the ability of certain routes to come up, or ultimately changing the network infrastructure to limit those routes. So yeah, that's definitely a challenge. And it always seems like these new routes are popping up.
And one of the really neat things with the Florida one is, although it's not implemented now, they do have the capability in the system to provide TIMS messages to connected vehicles. So the hope is, once the connected vehicle stance gets a bit further into the world, you'll be able to push those messages for the diversion route right into the car itself, so that the driver would be getting that in their dashboard themselves.
Right, excellent. Looks like the questions have slowed down here. I guess just one final comment from myself. I think that these are great examples of clustering analysis. So one thing that FHWA included in the update to the guidelines for microsimulation was the clustering analysis. And as you mentioned, I think it was what, 87% of incidences that warranted intervention were on, or I guess the cases were all incident based, and just the variable conditions that we experience on our freeway. So as we do these large freeway or system projects, I think that just stresses the importance of the clustering analysis and understanding that we're not really dealing with that average peak condition. There's many cases that we need these models to be able to respond to. So these are great applications demonstrating how we can do that.
Yeah, that's a really good point. I think we would be able to share at some point some of our analysis that shows just how broad the traffic can be, and how Tuesday to Wednesday to Thursday has enough difference to have an impact when you're looking at operations.
And I think if one of the things that Matt mentioned earlier too, just with the Florida project, when we're talking about typical day, common practice was Tuesday, Wednesday, Thursday, combine them, find the average, whatever. With that Florida project by itself, it was 14 different typical days, right? There is no such thing as one typical day. So it's
right.
That's where it's really, really important to have all
that. We only have about 3 or 4 minutes left, but 2 questions did just come in, so we'll try to squeeze these in. So the next one is, have you assessed the value of simulation as compared to use of detection in DMS for end of queue warning to avoid crashes? Is one more productive than the other?
So I can answer, honestly, we've done just one recently pilot with the Ministry of Transportation of Ontario, where we looked at the ability of using queue warning and predictions of incident condition, a prediction of when that speed drop is happening to be able to help with that ability. But we haven't, in fairness, we haven't done enough work into seeing how that could be used really to help avoid the events instead of just dealing with the events. And I think it's definitely something we're seeing, and it's coming.
Great. And then final question response here, similar to the previous discussion, have you noticed any impacts to your predictions being impacted by third-party routing apps like Waze, Apple Maps? Do you have a way of taking that routing into account?
Currently, we would, but we currently haven't worked with a partner that has been I forget what it's called, when a government agency is a partner with Waze. It's not the Friends of Waze, but I know there's a program where agencies can sign up with Waze and they share data back and forth. Neither of these 2 projects had that in place.
Yeah.
But it would be a really interesting aspect of this we're always looking for routing information, because it's one of the route paths is always one of the hardest things.
For sure, for sure. Alrighty, well, I think I'm going to go ahead and conclude the session here. We're just about at time, so thank you for attending our Oregon ITE SimCap webinar. I always look forward to these discussions. Hopefully we'll be able to do more of these in person, but I do enjoy having the webinar aspect to bring people from outside the local area in as well. So again, stay tuned to OregonITE.org for more events in the future. If you have any suggestions for future SimCap events, feel free to email OregonITE1@gmail.com. And thanks again to the Aimsun crew, and enjoy the rest of your day.
Thanks for having us.